Hello everybody, I will start my today another live coding session. So today I will solve this question, diameter of a binary tree. So in this question, I'm given the root of the binary tree and I will return the length of the diameter of the tree. The diameter of a binary tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root. The length of the path between two nodes is represented by the number of edges between them. Good. Okay. So firstly, let me quickly confirm my understanding of this question. So in this question, I'm given a binary tree, and let me confirm. Root is known or root can be known. So, yep, number of nodes in the tree is the range 1 to 10 to the power of 4. So 3. Root can be known. Yep. 3 cannot be known. Okay. Good. I confirmed something here. So which means there is at least one node. So maybe something like this. Yep. And for example, in this case, 2 and 3 is the longest path whose length is 2. Because length of the longest path between any two nodes in the tree. The path may or may not pass through the root. Longest path. The length of the path between two nodes is represented by the number of edges between them. So there are 2 edges. So in this case, I return 2. Okay, quite simple. Good. I will take a look at some more examples and I will try to think of the algorithm. But oh, by the way, I just want to confirm the input of this question is the root of the binary tree, and the output should be the length of the diameter of the tree, which should be integer. Okay, so now let me think a bit more complicated example. I will use O or circle as the node because number doesn't matter. So for example, in this case, the longest length should be here 1, 2, 3, 4. Let me add one more. So now it should be 1, 2, 3, 4, 5, or maybe another root 1, 2, 3, 4, 5 is the longest one. No. Wait a minute. So okay, let me change a bit. Let me add this one too. Okay, so in this way, longest one should be 1, 2, 3, 4, 5, 6. So I will return 6. And actually, it doesn't go through root. If I go through the root, it should be 1, 2, 3, 4, 5 at the longest, or 1, 2, 3, 4, 5. Yep. So I go through this node and node below that. Okay. So I think I can use the recursion for this question. Yeah. Oh, by the way, the brute force approach is that I choose, highest node in the path. Then I choose, left node and also right node, right edge node and left edge node. And right edge node and left edge node can be equal to the highest node. It's possible if left node or right node doesn't exist. for the highest node. Yeah. But I think that's the brute force approach. So for each highest node, choose every possible left edge and choose right edge and calculate the length. And I will return the global max length. Yeah. So I don't estimate the time complexity here because I already have better idea in my mind. But at least I can say it takes n times, in the worst case, there should be n divided by 2 left node and n divided by 2 right nodes. So n cubed time complexity, I guess. Yeah. So not so efficient. Okay. Good. So I will think of the optimized approach. So my observation from here is that for every path, there is only one highest node in that path. So for example, if I take this, the highest node should be here. If I take this path, the highest node should be here. Yeah. Or if I take just, if I'm given only this one, the highest node should be here. Or only the single node, in this case, this should be the highest node. So I can say, oh, no, it don't come here. Okay, so every time I can take the highest node, for highest node, the length should be, so node to left, longest length, path length till any left side reef. Yeah. Plus longest path till any right side reef, if it exists. If it doesn't exist, it should be 0. Yeah. So this should be the maximum length. So what I mean to say is, for example, if I take this node, the longest path till, any left side reef is this one. This is the one is the longest because it should take 3. Yeah. Paths. And here, from here, it should be this or this, which takes 3 paths until reaching it. Yeah. So in that way, I get 3 plus 3 is 6. So I can say the maximum path length which penetrates this node as the highest node should be 6. So I keep doing it for each node recursively and return the global max length. Yeah. So this is it. So I can use the recursion here. So definitely the recursion's interface should be, because I have to return max length theory, and I pass the node, and I will return, max length there's the reef. So yeah, in this way, max path ranks till any left side leaf can be fetched. Yeah, but also I want the global max ranks, max ranks here inside of this recursion, recursive function. So actually, this does two things. Number one, calculate max ranks, local maximum ranks here, and update global one. And after that, this returns the max ranks until the leaf. Yeah. So in the main function, I initiate the global max ranks, which should be updated inside of each recursive function, and then call this max ranks the leaf with root node, and then return this global max ranks after recursive function calls are all finished. Okay. So in this way, the time complexity should be O of n, because this node argument of the recursive function should be each node only once. So there should be n calls. And for each recursive function, it takes a constant time aside from another recursive function call, which can be excluded from the, when I calculate the time complexity by, multiplying the number of calls times time complexity of each recursive function. Yeah. So let me say that in this way. Number of recursive function call times time for each recursive function. So this should be n times 1. So it should be O of n. For space complexity, the only data structure I use is a recursion stack of this recursive function call, which is exactly as the same as the maximum height of the binary tree. And in the worst case, this tree can be like the linked list. So there are n nodes which is connecting, without any, without any siblings for each node. In that case, the rank should be n and height should be n. So it should be the space complexity. Okay. So that being said, I will do SaaS implementation. Initiate this with 0. And this should be the recursive function max till leaf. So this global max rank should be updated inside of this. And this should return max ranks till the leaf. And in the end, I call this with given root node and returns the global max ranks in the end. Okay, so now my task is to implement this max ranks till leaf method. So firstly, I will think of the base case. Again, sorry. So if root is actually the leaf node, I should return 0. Yeah, And if this given root is known, I should actually return -1 when I consider the calculation in the caller method, but it makes it complicated. So let me say the base condition should be the case if root is leaf node, not the null case. So root is not known and is leaf is root left. So this is the base case. And in this case, I return 0. Okay, so now either of the root of left or root of right exist. That being said, max length tail leaf should be like this. So yep. But I have to take care that root dot left or root dot right can be known. Yeah. I mean, either of them can be known. Both of them cannot be known, but either of them can be known. I will think of that case. If it is known, I would say it should be 0. I just want to ignore that. So maybe it should be minus mass of the infinity. Wait, is it correct? Yeah, I think I can just put 0 here. So I can say, let me name this as the, variable. Max, this should be left side, max length the leaf. And the other should be right side, max length the leaf. So with this, so return should be okay. So maximum of this or this. So I mean, I will return this in the end. Yeah. But I have one more task I have to do in this method, as I said, which is here, calculating local maximum ranks and update global max ranks. I will do that. So max plus ranks. I will say local max plus ranks be this plus this. And I will update global max ranks. Yeah, so this is it. Okay, so basically I'm done with the implementation. Let me check a little bit more. So yeah, basically max rank reef does two things. Firstly, update the global max ranks with the local maximum ranks. Yeah. And also it returns the length until the leaf node, any leaf node going down. Okay, so as the base case is the case when root is the leaf node. In that case, I return just 0. And I don't have to update global max length because the path length is just 0. So, and in line 57, I do call the recursive function to get the, maximum length until the any left leaf node going down, and also the right hand side also. And when I get that, local maximum length, path length should be the sum of them. So I update global max length with that. And in the end, I will return the bigger one of left max length tail leaf and right max length tail leaf. Okay. Let me walk through my code. So I will go with a very simple case. Firstly, if there is only one node. In this case, it should return 0. I will check it. In this case, root is global max length is 0, and I call this max length tail leaf method. Oh, I don't need self here. Okay. Okay, so and in line 58, root is not known, yes. And in line 59, root of the left is known, yes. Root of the right is known. So its leaf is not true. So in line 61, I return 0. So global max length is not updated in the end, and I return 0. Okay, good. For this case, it's okay. So now I've just covered, I haven't covered line 63 to 69. So I'd like to check these cases. So let's say this case, one more simple case. So in this case, it is expected to return 1. So firstly, global max length is initiated with 0. And max length tail leaf is called with root node 1. Yep. Okay. So here, in line 66, root of the left is known, but root of the right is not known. So its leaf is false. I go to line 70. And here, I want this left max and right max. So for left max, I call the recursive function again with root of the left, but root of the left is known, so it becomes just 0. So I don't call the recursive function from here. For right max, root of the right is now 2, node 2. So max length tail leaf is called with the node 2. Okay, and I have to calculate this. And because this node is the leaf, I'm actually pretty sure this returns 0 because it already confirmed in the first test case. So this returns 0 and this doesn't update global max length inside. So now this is 0. Sorry, and in line 72, as I can see, I have to do +1, which is now 1. So from here, local max length is max of these two numbers, which is 1. So global max length is updated with 1. Now it becomes 1. Yeah. And in line 79, I return maximum of 0 or 1. It should be 1. And this is as expected because from node 1, the maximum length tail leaf is 1. Yeah. And I go out of the loop, recursive function, and I go back to line 83 and return global max flex 1. Okay, so this is as expected. Okay, so good. So I covered line 73 and 74. I actually didn't cover in line 73 the left hand side expression, and then in line 74 I didn't test right hand side expression, but I'm pretty sure they're correct because of the symmetry of left and right. And in line 76 I covered it, 77 covered, 79 covered. Okay, so I'm pretty confident in my code, so I will submit. Oh, server don't need it here. Good. Okay, accepted. Okay, so I will quickly wrap up on today's coding practice. So today I solved the question, diameter of the binary tree, and I'm given the root node, and my task is to return the length of the diameter of the tree. So diameter of the tree is the any path length which goes through the nodes in the tree. Yeah. And in this question, I solved it in this way. So any possible node, I will consider it to be the highest node in the path and calculate the maximum path length, which penetrates that node as the highest node. For that, I want the path length until the leaf node on the left hand side, and also that in the right hand side. Yeah. So in the recursive function, it takes the root node, any node, which is thought to be the highest node, and it returns the maximum length until any leaf node, left or right. So in this way, I could solve this question recursively. So it worked perfectly. Okay, so that being said, I finished my today's coding practice. Thank you so much. Bye.